Today we're going to be doing 3.5 function notation. I can use function notation to evaluate a range for a given domain. So function notation, this is just showing that the equation represents a function, and so it's written with function notation. The only difference is that instead of y, you have this function of x at the beginning. Oops, that's a little too far over. So everything else in the problem stays the same. You are switching out y for notation that says f of x and then equals. So instead of y equals, you're saying f of x equals. And then the rest of the equation is just 4x minus 1. So the f of x is what the f stands for is the function of x. And we know that x is the domain. So it's the function of that domain. It's equal to this equation. So some other things to know is that the f of x part is the output because it takes the place of y. And x, as always, is the input. Function notation is especially useful for finding a value in a range that corresponds to a certain domain value. So the example here is that if f of x equals 4x minus 1, find f of negative 7. So find this function at negative 7. So the way you would write that is the function of negative 7 means 4 times negative 7 minus 1. And so you're just replacing, I did not like how any of that looked. You are replacing the x with the negative 7. Now, you can evaluate this. So what you do to evaluate this is 4 times negative 7 minus 1. And you can do that in your calculator, and it gives you negative 29. 4 times negative 7 is negative 28. Minus 1 is negative 29. And so a lot of people think that this is something new and something different, and it's not. It's just substituting in that one value for x. So in a problem like number 1, you are just doing 5 plus 7. That is it. That equals 12. That's your answer. In a problem like number 2, you are doing 3 times negative 3 minus 8. You can type all of that into your calculator, and that answer is, let's put some equals on here, I guess would be better. That equals negative 17, because you got negative 9 minus 8, which is negative 17. For one like number 3, you are substituting in 9. So you have 2/3 times 9 minus 1. So just to be clear on this, 2/3 times 9 is 6, and then you're going to have minus 1. So the answer here is going to be 5. But you can use your calculator to do this if you pull it up here, right? So let's get off this from yesterday. So you would do alpha y equals, enter. So then do 2 over 3. And then you're multiplying that by 9, and then you're going to subtract 1. So that's 5. So that's how you would do that in your calculator. If you have one like number 4, remember yesterday I talked about using the parentheses with the negatives, and it's very, very important to use those parentheses, especially when you are involving exponents. So this would be negative 4 squared minus negative 4. Notice how I wrote that with those negative 4's in parentheses. So when you type this into your calculator, you're going to have negative, whoops, not like that. I did that backwards. Negative 4 squared minus negative 4. So the answer to this is 20. If you left out the parentheses, you would not get 20. Negative 4 squared minus negative 4 is only negative 12. Much, much different. Do you want me to owe you $12 or do you want me to have my own $20? Big difference. So what is happening there is your square in your calculator thinks, oh, that square is just for the 4, and then we're going to make whatever that is negative. It doesn't understand that you're actually wanting to do square of -4, which is different, which is what you want because -4 is replacing x, not just 4. So just use the parentheses. It will make your life better. You will get things correct more often, and we'll all be happy. All right, for one like number 5, that negative is in front of the x. So that one, it's okay to do, well, let me write it down, to do it like this with the negative in front of. So this is what you're going to type in your calculator. And anytime that you have squares involved, I encourage you to use your calculator. I encourage you to use your calculator all the time. I mean, you probably don't need it on number 1. 5 plus 7 was 12. But these other ones, definitely just use it. So this one is a 1. See? Just use the parentheses. If I didn't use the parentheses there, it actually wouldn't make a difference, but you would have to remember to do 6 times 5. So using the parentheses makes a difference in that it automatically will multiply the things that need to be multiplied. Okay, for this one, I'm going to do -1/2 times -8 like that in parentheses, and then plus 9. So then for my fraction, I'm going to do alpha y equals, and I'm just going to do -1 on top. The negative, I just always put it with the top number. You can put it out in front of it, but you don't really have to. And then times -8 in parentheses plus 9. So that answer is 13. For this next one, I'm going to have 2 times -5 squared plus 4 times -5, that's a mess, minus 9. And so I'm going to type that in just like it looks with all those parentheses. Otherwise, that's a negative. So that square is not going to do what I want it to do if I don't have those parentheses there to tell it, hey, I want you to square -5, not just 5, and put a negative on it. Because it's not the same thing. A -5 squared, negative times negative, is positive 25. Not negative 25. So it is different. So you've got to treat it different. All right, so after you type it in, look at it, make sure it's right. So that's 21. And then the last one is an absolute value. So absolute value you can do in the calculator, but you have to be careful. So I'm going to go ahead and type or write what I'm going to put in. So I've got absolute value of -7 minus -7 squared. All of that in those absolute value bars. So what you do in your calculator is you're going to go to Math, which is under the green button on your calculator. You're going to go over to Number, and it's that very first one, that ABS. So it says input what your absolute value is in those parentheses. So those parentheses are acting like these absolute value bars. So in there, I'm going to have another set of parentheses for my -7 minus another set of parentheses for my -7 and then my square. Now I'm done. So you can see that that matches what's on the inside of my absolute value bars, and those parentheses are acting like my absolute value bars. So then we're going to enter that, and that is 56. All right, so just remember absolute value just means nothing in the answer can be negative. So if we did this without the absolute value bars, we're going to get -56, and then the absolute value bars make it be positive 56. All right, next page, we're going to actually cut out a lot of this because we're not required to do all of this anymore in Algebra 1. So we're going to cut out all the way to number 17. Okay, so number 17 is an application problem. Actually, let me just close that. I don't think I need that anymore. So anthropologists use the length of certain bones of the human skeleton to estimate the height of the living individual. And just in case you want to know, that's going to be the femur. The femur is your thigh bone from your knee to your hip. One of these bones is the femur. So I should have waited a minute and it told you that. To estimate the height in centimeters of a female with a femur length of x, the function is h of x, so height of x is 61.41 plus 2.32x. So if we know the femur bone is 46 centimeters, h of 46, then that's going to tell us how tall this person was. So it says to find h of 46 and then explain its meaning. So h of 46 means that we're going to do 61.41 plus 2.32 times 46. And now we can put this in our calculator. So I closed that a little too soon. So we're going to do 61.41 plus 2.32 times 46. So the x is the femur length. So we know her femur was 46 centimeters long. Then we put it into this formula that anthropologists have devised, and that tells us that our person is 168.13 centimeters tall. And so I'm going to put centimeters on here, and then I'm going to write over here to the side that 46 centimeter femur, except I'm going to spell femur wrong, equals 168.13 centimeter tall female. Is it female? Yeah. Okay. And the just in case you want to know, that function changes depending on if it's a female or a male. So females are shaped differently so that they can bear children, and so their leg length, their hip placement is different, and so they have to use a different formula for female versus male. Okay, so that was a little free science lesson there. On the last part here, we're evaluating given a graph. We kind of started this on the iExcel yesterday because you were given a graph and then you were told to find a missing number in the table. This is the same thing. So we know when it says f of a number that this number represents the x, and we are trying to find the y. That's what it's asking us to do. So for this problem, if we know we're talking about -3, then we would go to -3, which would be here, and then go up to the graph, and then go back over to see where that is on the y-axis. And so that's at 2. So f of -3 on this graph, on this parabola, is 2. Okay, I'm going to erase what I put on here and do it again for 0. So 0, f of 0 is on the origin. And so the graph is on that y-axis up here at 1, 2, 3, 4, 5. So f of 0 equals 5. I don't like any of that. That's not much better. Okay, let me erase that one. Then we're going to do 1. So f of 1 would be right here. So we have to see where that's at on the graph. And then we go back over to the y-axis to see that that is also 2. So remember, they can both have the same y. They just all have to be different x's, which they are. And then the last one is f of 2. So we're going to go over here to 2. And now we have to go down. And so it's very close, but we're just going to say that it's right there at -3. So you can see this is 1, 2, 3 down. So that's -3. Okay, Now let's look at this curve. This is a sine curve. So for the sine curve, we're going to start at -4 on the x-axis. So 1, 2, 3, 4. And then the sine curve right there is at 2. Okay. Now we're going to do 0. And because it is still on the origin, that is also 0. So x is 0 and y is 0 at that part of the function. All right, then for 2, we're going to go over 1, 2, and then we're going to get to -2 on the y-axis. And then for the last one, we're going to go over to 5. 1, 2, 3, 4, 5. And that one is at -1. So that's how you do that. That's kind of like working backwards. They've given us the graph, and we have to figure out what those y values are for that place on the function. Okay, so there you go. That's all of that for today.